Welcome back, students. Today we are going to study the mole concept, a part of which you have already studied in class 10. But anyways, we'll be going through the concept again because we'll be using this concept for further studies in terms of volumetric analysis, and of course we'll be using mole concept for almost all lessons in physical chemistry. So it's very important that you understand this concept well, and so we'll just go with what we had already done in class 10, and of course understand it in a better manner. Okay, now we know atoms react to form molecules in simple whole number ratios, but it is impossible to work with individual atoms because they are very tiny. In any laboratory, we must increase the size of the particles such as atoms or molecules or ions, etc., to the point where we can actually weigh them. So for a chemist, the unit of counting atoms, molecules, ions, electrons, protons, all these microscopic particles is in terms of mole. That is MOLE. Okay, and what does mole mean? Mole means it's a collection. That means when we talk about the amount of a substance, the one of the units that we use in terms of amount of a substance for microscopic particles is mole. Like we have dozen. Dozen means what? It means 12 units, 12 items. Okay, so if we want to buy a dozen banana, we'll say give me a dozen, give me 2 dozens. That means 2 into 12. So a dozen means 12. It's a number, a clubbed number, a collection of items containing that particular number. That's 12, a dozen. When we say a score means 20. So if we have a score of something, means that many 20 number of items. When we say, let me take a century, it means 100. Right? So a gross, when we say gross means what? 144 items. So the same way, in chemistry, the number of items, the amount of a substance in terms of a number is a mole. And what is that number? That number you have studied in class 10 as Avogadro's number. Okay, so a mole is the amount of any substance which contains as many elementary entities, whether it could be atoms, it could be molecules, it could be ions, as there are atoms in exactly 12 gram of carbon. That is a standard we have taken, right? 12 gram of carbon. Now we know experimentally through mass spectrometer, we have found out now that the mass of an atom of carbon is how much? That is 1.992648 into 10 to the power minus 23. That means if I have to have an understanding of one atom mass, it will be such a huge number, such a minute number, a complex number. It will be so impractical to actually use it in normal calculations. So then how do we find out what is Avogadro's number? Okay, so we know one mass of one atom of carbon is this much, 1.99, let me take it, into 10 to the power minus 23. And 1 gram atom, 1 molecular mass, we had studied that as a standard. So 1 gram atom of carbon is 12 grams. So how many carbon atoms are present in that 1 gram in 1 molecular mass? 12 divided by 1.992648 10 to the power minus 23. That will come out to be 6.02 into 10 to the power 23. Almost 602 hexillion. We're not talking about billions and trillions, we're talking about hexillion. It's approximately that. Okay, so Avogadro's number is a number which is telling me what is the amount of substance present, how many particles are present. It could be electrons, it could be protons, it could be ions, it could be atoms, it could be molecules, anything in terms of microscopic particles. Okay, so amount of any substance which contains this number, I can say Avogadro 6.022 into 10 to the power 20. Some books will give you 6.023 because this is an approximated value. Okay, so 6.022 into 10 to the power 23 buses. Oh goodness, the earth won't be enough to accommodate that. In fact, if you have 6.022 into 10 to the power 23 gems, that small chocolates that this children eat, small rounded shaped gems, if I take single piece of that to cover 6.022 into 10 to the power 23, I think the entire earth will not have that much space. That huge is the number 6.022 into 10 to the power 23. So, mole concept, a mole, what is mole? Mole is the amount of any substance which contains as many elementary entities as there are atoms in exactly 12 gram of carbon. And how many atoms are there in 12 gram of carbon? 1 Avogadro's number. That is represented as Na, or in some books you will have it as N. It is 1 mole. So 1 mole of any substance should contain how much? It should contain 6.022 or 23 into 10 to the power 23. Now it is important to know that while we use the term mole, we must specify the kind of particles, because the amount of a substance changes with the change in the nature of particles. For example, if I say 1 mole of sulfur atoms contains 6.022 into 10 to the power 23 atoms of sulfur, but 1 mole of sulfur molecule means S8, and when it is S8, sulfur molecule is S8, it means 8 into 6.023 into 10 to the power 23 atoms, or let me take molecules of S8. Therefore, a mole of sulfur molecules contains 8 moles of sulfur atoms, or a mole of sulfur atoms contain Avogadro's number of atoms. You're getting me? So it is very important to write what we are talking about when we talk about mole. So we have to mention whether we are talking 1 mole of atoms, 1 mole of molecules. Okay? Now, when we say the gram atomic mass, another example, when I'm talking about the gram atomic mass, that means atomic mass in terms of grams. Okay, so I have taken over here 1 gram atomic mass of hydrogen is 1.008. You can approximate it to 1. Okay, so it is 1. That means if I take this as 1 gram, instead of exclude that 0.008, then if I take it as 1 gram also, that means that 1 gram should contain how many number of atoms? It will contain 6.022 into 10 to the power 23 number of atoms, and that is 1 mole. That means 2 grams of hydrogen, that means 1 molecule, the molecular mass of hydrogen, that is 2. So if 2 grams of hydrogen will contain 6.022 into 10 to the power 23 molecules, or 1 mole of molecules. Okay, therefore it is very important that we explain or we write down what we are talking about, whether we are talking about atoms in terms of mole or whether we are talking about molecules. The mass of 1 mole of a particular type of elementary entity expressed in grams is called its molar mass. Okay, so mass of 1 mole of atom, mass of 1 mole of molecules, mass of 1 mole of ions, that is called the molar mass. That means mass of 1 mole of anything is its molar mass. And molar mass is numerically equal to, very important, molar mass is numerically equal to, let me take another pen. numerically equal to its relative atomic mass in AMU. Okay, that means 1 gram mole of oxygen molecule would be molar mass of oxygen molecule, that would be 32 grams, because atomic mass is what? 16. Okay, so molar mass is the mass of 1 mole of any entity, and the volume occupied by that molar mass, the volume occupied by 1 gram mole, the volume occupied by 1 gram molecular mass at STP is called its molar volume. And how much is molar volume? 22.4 liters. This you had already studied. Okay, so molar mass, mass of 1 mole of any particular entity. Molar volume, the mass occupied, the volume occupied by 1 gram molecular mass at STP is called its molar volume, and that comes to be 22.4 liters. That means 6.023 or 6.022 into 10 to the power 23 number of atoms of hydrogen, let it be take, will occupy 22.4 liters. 6.023 into 10 to the power 23 molecules of, let me take, oxygen will occupy 22.4 liters. So the gram molecular mass of any gas at 0 degree and 1 atmosphere pressure, which is supposed to be the STP, standard temperature and pressure, is called its molar volume. And what will be molar volume? Molar volume would be 22.4 liters. Okay, these are certain numbers which you have to remember always. Then the next thing that you have is, we have studied molecular mass. Molecular mass you have studied molecular mass. So 1 molecular mass is 1 mole, right? So 6.023 into 10 to the power 23 is 1 mole. That's a number. It's just a number. Okay, this many number of units. Okay, I have told in class 10, I think I remember when I was teaching about mole a little bit, we had seen what exactly is that number, 6.023 into 10 to the power 23. 6.023 is it's a huge number given, and that name Avogadro's number is, or Avogadro's constant, is given in terms of as an honor to Avogadro, right? So that number was given as its Avogadro's number as an honor. And we know 1 molecular mass. What is 1 gram molecular mass in terms of moles? The same way we have a formula mass. Now what is this formula mass? The sum of the atomic masses of all the atoms present in the chemical formula of a substance is called its formula mass. Now you'll ask me, what's the difference? NaCl is NaCl. So formula molecular mass of NaCl would be like 23 plus 35.5. Correct? And molecular mass is also 23 plus 35.5 for NaCl. Correct? Because in that substance NaCl, both the molecular formula and the chemical formula are the same. Water, 18 grams. So molecular formula H2O, chemical formula H2O, molecular mass 18 grams, chemical formula mass 18 grams. But when substances have chemical formula and molecular formula slightly different, like for example aluminium chloride, the formula of aluminium chloride is AlCl3. Good. It is AlCl3 because that is how aluminium has got 3 as its valency, chlorine 1. So formula is what? AlCl3. Very good. That's the chemical formula. But how does it exist? Its molecular formula is Al2Cl6 because it exists as a dimer. So what would be the formula mass of aluminium chloride? The formula mass of aluminium chloride would be, in terms of aluminium and 3 chlorines, we'll have 133.33 AMU. And what will be the molecular mass of aluminium chloride in terms Al2Cl6, because it is existing in the form of a dimer? That would be 2 into atomic mass of aluminium, that is 27, you can approximate it to, or 26.98, and the chlorine is 35.5, so 6 into 35.5, total will come to around what? 266.6 AMU. So there is a difference between the molecular formula and the chemical formula. But it is not there for all molecules. No. Some show such characteristics, like sometimes it is in the form of a dimer or a trimer. So there you have a slight difference in its formula mass and its molecular